Welcome to the fascinating world of research methodology. Today, we are going to explore two of the most fundamental pillars of any scientific investigation: descriptive and analytical research. Whether you are studying animal behavior in zoology or analyzing complex biological data, understanding the difference between these two approaches is absolutely critical. Let us dive in and see how they shape the way we understand the world. To start, I want you to imagine that you are a detective who has just walked into a room. On the floor, there is a beautiful glass vase, completely shattered. If you pull out your notepad and simply write down the facts, that the vase is broken, the window is open, and there is water on the floor, you are conducting descriptive research. You are just observing. However, if you start connecting the dots to conclude that the wind blew the window open, which then knocked over the vase, you are now conducting analytical research. In simple terms, descriptive research tells us what is happening, while analytical research tells us why or how it is happening. Now that we have a basic intuition, let us look at the formal academic definition of descriptive research. This type of research includes surveys and fact-finding inquiries of different kinds. Its main purpose is describing the state of affairs exactly as it exists at present. In many fields, we quite often use the term ex post facto research for these studies. The defining characteristic of this method is that the researcher has absolutely no control over the variables. You cannot manipulate anything. You can only report what has happened or what is currently happening in your study population. Building on those basic facts, we move to the second type. In analytical research, the researcher has to use facts or information that are already available and analyze these to make a critical evaluation of the material. While descriptive research stops at observation, analytical research digs deeper. It focuses on uncovering the hidden relationships between different variables. It asks the difficult questions about cause and effect. You are no longer just a passive observer recording data. You are actively evaluating that data to explain the underlying mechanisms and causes behind the phenomena you are studying. You might be wondering why we need to separate these two types of research and why they both matter so much. We need descriptive research because we cannot understand a complex problem without first knowing the basic facts and establishing a baseline of truth. For example, if a government does not know how many people live in a city, they cannot plan for hospitals or schools. On the flip side, we need analytical research because facts alone do not solve problems. We must understand the relationships between variables to make predictions and improve our world. Simply put, without descriptive research, we have no data. But without analytical research, our data is completely useless. Even though research methodology is primarily a theoretical subject, we can represent these concepts mathematically to understand their core logic. When we conduct descriptive research, we are essentially measuring a specific variable across a population to find its central tendency, like an average. The most common mathematical tool for this is the simple arithmetic mean. Let us look at the formula. The symbol mu represents the population mean, which is the average value we are trying to describe. The symbol n represents the total number of observations or people in our study. The symbol x sub I represents each individual measurement we take, and the summation symbol tells us to add all those individual measurements together. If the value of n increases, our descriptive data becomes much more reliable because we are surveying a larger portion of the population. Before we move on, let us see this with a concrete example. A university administration wants to understand the current study habits of its freshman class. They simply want to describe the current situation, not why it happens. They survey 5 random students and find they study 10, 15, 12, 18, and 20 hours per week. To analyze this descriptive data, we calculate the arithmetic mean. We add up all the individual values in the numerator, which gives us 75. We divide by the denominator, which is 5, because we surveyed exactly 5 students. This aggregates all individual variations into a single total sum. Dividing 75 by 5 gives us a final mean of 15 hours. We have accurately described the freshman class without explaining why they study this much. This is the pure essence of descriptive research. Now that we have mastered descriptive data, let us look at how we represent analytical research mathematically. Because analytical research looks for relationships and causes, we often use a linear equation to see how one variable affects another. The standard model is y equals m times x plus c. In this model, the variable y represents the dependent variable, which is the outcome we are trying to explain, like a student's test score. The variable x represents the independent variable, which is the factor we think causes the outcome, like hours spent studying. The symbol m is the slope, which tells us the strength and direction of the relationship. If m is large, even a small change in x causes a massive change in y. Finally, c is the baseline value when x is 0. This linear model leads us to an important mathematical tool. To truly evaluate the relationship between our variables, we need to calculate that slope, m. We use the standard slope formula, which divides the change in the dependent variable by the change in the independent variable. In this formula, y2 and y1 represent the outcomes, such as the test scores of 2 different students. The variables x2 and x1 represent their corresponding inputs, like their study hours. The numerator calculates the total difference in scores, while the denominator calculates the total difference in study time. By dividing these 2 differences, we find the rate of change. This rate of change is the absolute core of our analytical investigation, telling us exactly how much one variable impacts the other. Let us apply this formula to a real analytical question. The university now wants to know if studying more actually results in higher test scores. We take data from 2 students. Student A studied for 10 hours and scored 70 points. Student B studied for 20 hours and scored 90 points. Our strategy is to find the analytical relationship by calculating the slope of the line connecting these 2 data points. We substitute our values into the formula, 90 minus 70 in the numerator and 20 minus 10 in the denominator. This simplifies to 20 divided by 10, giving us a final slope of 2. This is a powerful analytical conclusion. It tells us that for every 1 additional hour a student studies, their test score increases by 2 points. We have uncovered a hidden mechanism. Now that we have calculated the math, let us look at a visual summary of these 2 paradigms. On the left side of the diagram, you see the realm of descriptive research. It is represented by a clipboard and a simple bar chart. This is all about fact-finding, observing, and recording what is happening right now without changing anything. On the right side, you see analytical research, represented by a magnifying glass zooming in on a line graph. Notice the upward trend line and the equation y equals m times x plus c. This side is investigating the why and the how. It is looking at how the variables on the x and y axes relate to one another. The diagram perfectly captures how analytical research builds upon the basic facts gathered by descriptive research. To wrap up our journey, always remember that descriptive and analytical research are two sides of the same coin. You cannot truly have one without the other. Descriptive research lays the essential foundation by accurately reporting the facts and answering the what, completely free of any variable manipulation. Analytical research then builds upon that solid foundation by digging deep into the data to answer the why and how, uncovering the hidden relationships that drive the phenomena we observe. As a researcher, you will constantly rely on both of these powerful methods to paint a complete, accurate, and meaningful picture of the truth. You now have a solid understanding of both approaches.